another tutorial on inheritance in Python. So the next and maybe the last type of inheritance we are going to cover in this inheritance section is the hybrid inheritance, which we'll be covering in this tutorial. Hybrid is actually a thing made by the combination of two different elements. Now what are those two different elements that make up hybrid, a type of inheritance? So those two types are multi-level inheritance and multiple inheritance. This means that a program having multiple inheritance as well as multiple inheritance is known as a hybrid inheritance program. So let me give you an example to show how hybrid inheritance is done. So I will just move on to PyCharm, and in PyCharm I'm going to have a class named parent, and this parent class I'm first going to have an initializer function. You might have noticed that I do not often use this initializer function, but this is a very important programming technique and a programming practice, and a good programming practice I must say, to always define this initializer function, because this is a constructor and this must be initialized. So in this constructor function I'm going to simply print out constructor, nothing else. So the next thing we need to do is that I want to have a method named parent method, and this parent method is going to print out parent method. And the next class we are going to have is going to be the class named child. It is going to be inherited from the parent class, and this is going to have an initializer constructor function, and this constructor function is going to print out the very same. It's going to just print out constructor. The next function this child class is going to have is the child method, and this class is going to print out child method. Alright, so the next class we need to have is the next child, and this is going to be extracted from the parent class, and it's going to have a constructor init function, that is going to print out constructor init. Badly misspelled it doesn't matter. And we are going to have a next child method as well. The next child method is going to print out next child method. Let me just correct the spelling of this, since it's going to create problems when we are going to call it. So this, as you can see, is that this is multiple inheritance so far. So this means that we have achieved one level, or you may say one module of a hybrid inheritance, that we have achieved multiple inheritance in our program. But to achieve a complete hybrid inheritance and to call it a program of hybrid inheritance, we also need multi-level inheritance in this. So we are going to create one more class that is going to have multiple inheritance, and is going to, let's call it multiple, and this class is going to extract the child class, comma, the next child class as well, and this is going to have an initializer constructor function as well, and this initializer constructor function is going to simply print out constructor. I've been very bad at typing constructor. Alright, so the next method it's going to have is multiple method, and this multiple method is going to print out multiple method Alright, multiple method I think. Alright, doesn't matter with the spelling. So good enough. So now you can see that we have a class named parent from which two classes are extending. Sorry, we have two classes that are extending a parent class or a parent class that extending to child classes, and these two child classes are then extracted from this multiple class named multiple. This makes it multi-level inheritance because we have a level like this, and then we have got two levels like this, and then a level like this. You've seen that picture of a diamond or a D in the multi-level inheritance program, and you know that was also complexity level, and I explained the complexity level in the multi-level inheritance. This is the same. This is going to form the same hierarchical diagram. So this is now hybrid inheritance because we have multi-level inheritance. You can see over here that we have multi-level inheritance over here, and as well we have also multiple inheritance right over here. So hope you have got the concept, and you already know that how methods and so you already know that how methods are extended in this type of programs when I explain that diamond level complexity issues to you. So these are going to be called in the very same way, and if you change one of them and do not change the other of them, you've seen all of those scenarios in the break. If you don't understand what I'm talking about, go to the multi-level inheritance tutorial and go through it again to see how all of these classes are going to be called and how these are extended from each other and how making a change in one affects the other, or all the scenarios you can see in the multi-level inheritance topic. So with me, that's all. Thank you so much guys for watching, and I'll see you in the next tutorial. Welcome you to another tutorial on Python. In this tutorial, we will be covering a very new concept named method overloading. Defining a method with the same name but changing the number of arguments that function can be called with is called method overloading. For example, we have a function named run. We can now call this function using 0 arguments, 1 arguments, 2 arguments, 3 arguments, or whatever number of arguments we like. For example, we have a function named run. Now we can call this function using 0, 1, 2, 3, and whatever number of arguments we like. So let me just give you a quick example to show what is method overriding and how it is done in Python. So I will initialize a class name, let's say overloading, since I'm explaining overloading in this. And this is first going to have an initializer function. And it's going to print out constructor. You know what is the purpose of the constructor? It's used for initializations. So the next thing we need to do is that I will define a function named run, and this run is going to, for example, have an argument named as name, and we are going to set it to none. Now what does this none mean? This none means that if we pass something to this as an argument, then it's going to receive that and use it as an argument. But if we pass nothing to this function and we pass no argument to this function, then it doesn't matter at all. So it's going to simply print out, but let me specify some conditions over here. It's going to say that if name equals to none, then it's going to print out I received nothing. Else if it receives something, it's going to print out I received some arguments. Alright, so let's end this class and call over here. Alright, so let's define an object named O for that overloading class up there. And we are now going to call O.run. So we have passed in no arguments, and if I just run it now, it says I received nothing. And if I just pass on now something, let's say where to it, and now run it. It say I received some arguments. So when we type in name equals to none, you have seen the default values for arguments. So if we set the default value for an argument as none, then it doesn't matter if we pass something to it or if we don't. If we pass something to it, it's going to use it, and if nothing is passed to that function, that function barely ignores that argument. So when we call it using nothing, it says I received nothing because we passed nothing to it, and if when we pass something, it says I received some argument. You can change the number of that. For example, you can type in like age equals to none. So we can type in the number of arguments we want. So I hope you're clear about this concept. So in the next tutorial, maybe we'll be covering much more interesting stuff like that as well. So that's it for now. Thank you so much guys for watching, and I'll see you in the next tutorial. And I'm back with another tutorial on Python. In this tutorial we will be covering operator overloading. You now at least know that what is overloading. A single thing doing different jobs is actually called overloading in the language of computer programming. So operator overloading is a specific case of polymorphism in which operators are treated as polymorph functions and as such have different behaviors depending on the type of arguments. For example, you have seen the case of plus operator. It adds numbers as well as it's concat two strings. Hence, if we use the plus operator for integers or float values without quotation marks, then it will add those two numbers, and if we specify string in quotation marks and apply the plus operator on it, then it will concat those two strings. Let me show you how this is done. So I will just move on to PyCharm, and in here if I initialize two variables, a equals to 2 and b equals to 3 and c equals to a plus b, and if I just print out this C and run this code, so now the plus operator has act like an addition operator and has added those two numbers and give me a 5. Now if I just change this and make d equals to a string, let's say Omer, and e equals to another string that is going to have Khan. So now if I have another value and I concat these two numbers d plus e, and if I just now print out this f right over here and just run this code, it says Omer Khan. So for the first thing it has added these two numbers, and for the second case the plus operator has concat these two strings together. This means that the plus operator is overloaded and it will perform the functionality we want it to perform. So now to a complex example to show you how operator overloading works. So I will just remove all this. So now I will use the plus operator to add two objects, and I will show you this by calculating the area of a circle. So I will make a class named circle, and in that class we will have an initializer constructor function, and in that constructor function we are going to receive one argument that is going to be the radius. We are going to initialize this radius using this constructor function for this class called circle. So in here we are going to write in self dot radius equals to radius. Good enough. So now moving on to the next function is we are going to set the radius. The second function is going to be set radius, and this set radius function is also going to set the radius for us, and that's called self dot radius equals to radius. We need an argument over here as well, radius. Alright, So the next function is going to be the getRadius function, and in this getRadius function we are going to receive no argument, and in this we are going to only return whatever radius we have now. So we are going to write out self dot radius. Alright, now so the next function is going to be the area function that is going to calculate the area for us, and it's going to receive nothing, and this is going to simply return mat.pi. That stands for, since the formula for calculating the area of a circle is pi r square, so we need a pi, then we need the radius over here, and then we need pi r, and then we need a square, so we are going to write out 2 over here. So good enough. So one more thing, we need to import the math class over here since we are using the pi function over here. So we are going to import math. Alright, so here we have now. So now the next thing we need to do is that we need to have a function that is going to add those two areas together. So I will just create a function named add, and in that function add we are going to receive another. Now what is that another? I will show you what is this another. So in this we are going to return and it's going to have self dot radius plus another dot radius. So this another is actually the radius that is going to be used for the other object that is going to add the second object that is going to be passed to this function. So the next thing we need to do is that we need to create objects for this. So the first object is going to be C1, and it is going to be passed to circle class. Alright, so we have this error over here since C need to be in capital, since Python is case sensitive as I told you earlier. So it is going to be circle, and we are going to pass out radius as 6, let's say, and we are going to simply print out C1 dot get radius. Alright, good enough. So we have this error over here. What is the problem with this? We need to add this object right over here, self dot radius. Yeah, that makes it cool. So let me just run it now, and it says 5 because we have only called the getRadius function, and this getRadius function has returned whatever we passed on. So now this object references to 5. So now we are going to initialize one more object named circle, and in here we are going to pass, let's say, 6, and we are going to print out c2 dot getRadius, and we are going to run it again and return us 5 and 6. Now C1 contains 5 and C2. So now I'm going to add these two objects in an other object named C3, and I'm going to add C1 plus C2, and now I'm going to call the getRadius function using this C3. So I'm going to call out getRadius using C3. I'm going to type out c3.getRadius, and it's good enough. So I'll just run it now, and it says 11. It has added the result of these two objects. This means that the plus operator is overloaded, and it can not only add to integers, to floats, and it can not only concat to string, but it can also add to objects, since the plus operator is overloaded in Python, and this is known as operator overloading in Python. So hope you're clear about this concept. If you're not, go through the video again and again until you are clear. So that's it with me. Thank you so much guys for watching, and I'll see you in the next tutorial.